Hello and welcome to TidyX episode 128. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. And today we are kind of kicking it off with Advent of Code Day One, even though it's like day, I don't know what
You know,
day, I don't know what day we're up to
whatever
now,
day
but
it is. We're definitely well
whatever day
into the
it
month of
is,
December at this point. But
we decided to pull the day one riddle. For those that don't know, Advent of Code is a daily riddle leading up to the Christmas holiday. Every day there is a new kind of riddle to solve in some sort of computer sciencey way, and you are free to solve it in whatever coding language you'd like. We will go ahead and solve it in R, obviously, since this is an R show. And we have two ways of doing it. Ellis has one way, and I have another way, and hopefully other people can write in with a third or a fourth way,
yeah,
because there's
no,
many ways to do
there's
it.
the great thing about these problems is it's more trying to get you to think about the problem and think about it in a computer sciencey way, as opposed to like this is the one answer,
Yep.
and this is the one language you got to do it in. So it's pretty great for doing that. Also, as a quick reminder, if you like what we're doing and you like this episode, be sure to like and subscribe down below if you're watching on YouTube, or just go to YouTube and like and subscribe. We also have a Patreon account. If what we've done has helped you in any way and you'd like to give back, we love doing this, but we donate a lot of time to this. So if you want to contribute a little bit to us, please sign up to be a patron. All right. So the idea for this problem is there are some elves that exist, and these elves have food in their like knapsacks or whatever, and this food has a certain number of calories they've got to have, and so they've recorded it for you in the problems set data set, and it kind of looks like this, where it's just kind of a stack of numbers. Where, for example, an elf has 1,000, 2,000, and 3,000 calories. And then another elf has 4,000 calories, and another elf has 7,000, 8,000, and 9,000 calories. However, the difficult piece about this problem, at least the vaguely difficult piece, is the fact that they don't actually have indexes in their data set. What they actually have to differentiate between your different elves is just a space between the numbers.
Mhm.
And so this sort of thing can happen pretty regularly. Like this may be a computer science problem and trying to get you to think about it in a different way, but sometimes you are provided data where the structure of the data is what tells you information about what's contained in it, not like labels and actually having it being really clear.
Mhm.
And so this
Yeah.
is this is a like a specific problem to this, but it does expand to thinking about how you might approach the sort of problem in a more general sense. Um, and so basically the idea is they want us to go through and figure out this first question is how many total calories is the elf with the most calories carrying? And then I've solved this already. This is logged out of my account. But the second question is what is the total number of calories for the top three elves? So the top three most calories, or elves carrying the most calories, what is the summation of that? So we're going to go through two different ways that you can solve this problem. One's kind of using a more base R approach, that's for me, and then Patrick's is taking a more tidyverse based approach. So let's get this going. We're going to load library tidyverse, even though I don't actually end up using it. I use this function most of the time when we load in data. We're using like read table, read underscore CSV, something like that. In base R, there's a function called read lines, and what read lines does is it kind of does what it says on the box, right? Where it just reads in every single line from a text data set. Does no parsing, does no separation. It's kind of like, all right, here's your data. Here's the files, and the only separation is here. I can read this in is the separation by each line. So we can look at the data here, and so we can see that it's 3264, 4043, 2537, and if you do a quick, let's do head. Well, this one I should zoom in a little bit so you can see what I'm talking about here. As you can see, this first entry is 3264, which matches. So basically, new lines mean new entries in our vector here. So now what we can do is, okay, we've got this information, and we know that the way that it treats these blank spaces here is it's going to actually drop in an empty character. So let's actually print this out to 15 so that we can see there's this empty character here. So we know that is going to indicate, Okay, new elf time. This is a new elf. So what we can do is we can do sum of this vector here where it's an empty character, because that is going to tell us this will turn it into a Boolean vector of trues and falses. When you do a sum on a Boolean vector, falses are considered 0 and trues are considered 1. And so that'll give us the total number of splits for every elf, and then we add 1 because we know that there's the first elf. Right? So that gives us the n number of elves that exist. The only reason I'm using this is to pre-allocate a numeric vector. So I'm going to use the vector function. I'm going to say it's type numeric, and length is n elves. So you don't technically need to do this, but I like pre-allocation. It speeds things up in R, so it's just a good practice to do. So now we've got this numeric vector, all zeros, because it knows it's numeric. It just doesn't know what value to drop into there. Now what I do is I do elf index is 1. So I'm going to say the first elf. We're going to start with elf number 1, and then we're going to loop over the vector that I read in here. So it's going to read this line, then this line, then this line, then this line, then this line. It's going to go for each one of those entries. If it's blank, increment the elf index by 1. So I'm starting at 1. When it hits that first one, it's going to go, oh, now it's 2. When it's the next one, now it's 3. So now I can use that as my index to then start summing values together. I'm going to then, into my elf level calories, say each entry is 1 elf, and I am going to basically do a cumulative sum in the sense of it's going to add back to itself its original value. So for the first time, it'll be adding 0. Pull that out here. And then the new value from the vector, or from the data set here. So in that case, 3264. And then it'll loop over it again, and it'll go, hey, well, it still haven't progressed forward. So I'm going to re-pull in the 3264 because I dropped it in this entry here. And I'm going to add 4043. And so now it's going to be like 7,000, give or take. It's going to loop over again. It's going to add 2537 and loop over until it's got the cumulative sum for elf 1. Once it hits that empty character, it's going to, okay, now I'm elf 2. Start the process over again. And so this is kind of a brute force-ish kind of approach. We're going to run that, but as we can see, my computer's relatively fast. I was pre-allocating, doing all the good things. So I was able to run that really quickly. Then which elf has the most calories? I'm able to use the max function to give me that. And so that is 72070. So that is the elf with the most number of calories, and that is the total number of calories that it has. And then for answer number 2, what is the top 3 elves? What is the sum of their calories? So I'd use a sort function on that vector that I created, and I say decreasing equals true. That way it starts with the topmost and goes down. I pluck out the top 3, and then I call a sum on that, and that'll add all the calories together for me, in which case that answer is 211,805. And I know these are the correct answers because I dropped them into Advent of Code already, and they told me it was right for my data set, not necessarily for yours, but this algorithm should work for you as well. So that is how I solved it in base R using for loops and lists, or not even a list, I guess a vector, a pre-allocated vector. Yeah. Patrick, how did you approach this?
All right. So what I did was I actually used tidyverse because perhaps there's a situation where I want to create the indexes and look at which elf it was that has the highest calories, or which had the 3 highest calories. So the first thing I did was I used a read delim, and that's going to let me read in the data set in this text file. I set header to be false, so basically that's just going to give me like a generic column header like v1, variable 1, v1, v2, etc. And then I have to set this little argument here called blank lines skip equals false. If I don't set that, it's going to compress everything down into a long, just a long column of data. And effectively, I miss where each new elf is going to be because I want them to be in NA. So when we run this, we end up with a data frame that you can see has an NA there at row 13, so that everything from 1 to 12 is going to be elf1, and then everything from 14 to row whatever is going to be elf2, et cetera, et cetera. It's a relatively long data set. Okay. Oh,
Just for it's the
yeah.
2,300 entries, so like
Yeah.
not small.
Mm-hmm. All right. So how are we going to do this? We start with that elves data frame that we just loaded up. I'm going to go ahead and rename variable one v1 to calories, since that's what we're dealing with. I just want to make sure I know what I'm dealing with. My first goal is to identify whenever there's a new elf. And remember, anytime we see an NA row, that's going to be a new elf. So I'm just going to create this little indicator for myself that basically says, hey, if you see an NA, just drop a 1 in there to start with. And so now I'll end up with a bunch of rows that have NA, and then they drop a 1 in. So there you can see, okay, oh, new elf is starting here. New elf starting now. Okay. The next thing that I do is I'm going to group by that new elf column, and I'm going to create an elf ID. And so what I'm going to do is I'm going to seek along that new elf column. So basically what it's going to do is it's going to create a row of counters for all of those NAs. And then when it hits it's going to create when it hits a new elf number, like a 1, it's going to drop a new number in and count. So the first one, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 1, 2, 3, 4, 5, 6, 7, 8, whatever for elf 2, etc. I just add the 1 here at the end of this so that every time it hits a new NA, a new elf, it basically just hits a 1, adds a 1 to it, because I want to make sure that I know that there is a first elf up at the top. He's not a 0 elf, right? And then what I do with that is I have this now, and I want to get rid of the counting rows because I don't really care about those. I just care about the elf ID, similar to the way that Ellis set up the ID indexes. So what I'm going to do is I'm going to say, hey, anytime there's a NA in that new elf column, it means it's pertaining to the same elf that's still there. So just drop an NA in that as well. And then anytime that it's not an NA, I want to keep the actual ID. I want to keep the actual index of that elf. And so if we run that, now we're going to see that we've got, okay, so there we go. So there's where elf 2 starts. So everything above that is elf 1, and then elf 2 is going to be all the guy, going down, and then elf 3 and elf 4, etc. So I ungroup that, and I'm going to use this handy fill function that we've looked at before, where I'm going to say, hey, take that elf ID column and fill everything going upwards. So basically, it's going to take that 2, and it's going to say, oh, cool. Everything above this is an NA, so we're just going to drop a 2 in that. And then everything above after the next one is going to be a 3 and a 4, etc. And so there we can see that. Great. Now, remember, that elf that's just starting out is actually elf 1. So I'm going to subtract a 1 from that elf ID. Then I just get rid of the new elf column because it becomes useless. I group by our elf ID because now we have our indexes, and I summarize the total calories. Remember to remove NA because we have an NA row every time, because that's how we knew a new elf was starting. And then I arrange them descending by total calories. So if we run all of this, we effectively get a data frame of elf calories. Yay, there we go. So elf ID 40 was the one that was carrying the most calories. And then if we want to get the top 3 summed together, I just use slice, and I say, hey, slice out those first 3 rows and summarize over those, sum them together. And that gives us our total caloric count that the elves are bringing with them on their journey from the North Pole. So there we go.
And so yeah, and that is 2 different approaches you can take to calculate the answer to the situation here, but more generally, how can you start using the structures of the data itself to help give you identifiers for elves or players or whatever other things that you're trying to measure without the traditional proper index, because sometimes that doesn't exist.
Totally.
But yeah. So that is Advent of Code Day 1. If you like us solving Advent of Code, please leave a comment down below so that we know that we should do more of these, because there's 25 this year, and they're going to vary in complexity. They're going to get more and more difficult. This was a relatively simple problem, but this was day 1. I have not gone to go see the current days, but I do know that they are already getting relatively difficult. Uh, and then you can also see the ways that other people are solving it on Twitter. At least I see people sharing on Twitter their solutions to these, the advent of code. So that's always really fun to kind of compare the way that you solve it against the way that other people solved it, because we all think about things in slightly different ways, and so it's kind of fun to compare. And you might learn something new, not just from us, but from your fellow R programmers.
Mhm.
So
Cool.
with that, I guess we're going to call it for episode 128. Thank you all for joining us. As always, my name's Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
My name's Patrick Ward. You can find me on Twitter at OSPPatrick. At tidy_explained is where we both are on Twitter. Tidy.explained@gmail.com is where we both are at email. You can always, as Ellis said, drop a comment, like and subscribe on that YouTube channel, drop a comment, question down below, drop a solution to Advent of Code Day 1 that might be different for ours. And if you feel like any of our work has positively impacted yours and you want to give back to us, we do have a Patreon page, and we appreciate anything that you may give.
Thank you all so much, and keep on exploring your world.